An F-35 Lightning II screams across the Nevada desert at 1,200 miles per hour. But inside the cockpit, the pilot isn't just flying. They're being drowned in a sea of invisible data. And that's where a new kind of intelligence steps in. This is Project Overwatch. It's not a remote-controlled drone or a simple autopilot. It's a tactical AI model recently flight tested at Nellis Air Force Base, designed to live inside the world's most advanced fighter jet. The goal? To give the pilot a digital wingman that thinks in microseconds. And the way they're doing it is genuinely brilliant. Let's break down how this silicon brain actually works in the heat of battle.
Modern air combat isn't about who has the fastest jet anymore. It's about who has the best information. The F-35 is basically a flying supercomputer, but even the best pilots have a limit to how much data they can process at once. Every radar ping, every radio emission, and every unknown contact on the screen requires a decision. In a high-speed dogfight, that mental tax is massive. Project Overwatch is built to pay that tax for you. By autonomously sorting through the noise, the AI identifies what's a threat and what's just a distraction. It's like having an extra pair of eyes that can see across the entire electromagnetic spectrum simultaneously.
During the recent test at Nellis, the AI wasn't just sitting in a lab. It was integrated directly into the F-35 systems, flying real-world patterns to see if it could keep up with the chaotic environment of the Nevada Test and Training Range. The results were a massive milestone for the program. The AI successfully processed complex electronic emissions and provided real-time combat identification, or CID, for the pilot. This is where the tech gets really interesting. It's one thing to identify a plane. It's another to identify a specific radar signature from 100 miles away while pulling 9 Gs. Overwatch did exactly that, and it did it without breaking a sweat.
So how does a piece of software actually talk to a fighter jet? It's all about the architecture. Project Overwatch uses a tactical edge computing model, meaning the AI doesn't need to call back to a central server. Everything happens locally, on the jet. This is crucial because in a real conflict, you can't rely on a satellite link that might be jammed or intercepted. The intelligence has to be right there with the pilot. This local processing allows for near-zero latency. When the AI sees a threat, the pilot sees it instantly. It's a seamless fusion of human intuition and machine speed that we've never seen in a cockpit before. But to understand why this is such a big deal, we need to look at the numbers. Because the sheer volume of signals Project Overwatch has to sort through is staggering. We're talking about the entire electronic fog of war. In the next module, we're going deep into the silicon. We'll see exactly how the AI distinguishes a friendly radio from an enemy jammer, and how it handles the dreaded unknown contact. It's a masterclass in pattern recognition at Mach 1.6, and honestly, it's one of the most clever engineering feats I've ever seen. Let's dive in. The heart of Project Overwatch is its ability to process electronic emissions. Think of every radar, every radio, and every cell tower as a unique fingerprint in the air. The AI is trained to recognize these fingerprints instantly. This is called ELINT, or electronic intelligence. Normally, a human analyst would spend hours poring over this data. Overwatch does it in milliseconds, identifying the make, model, and intent of the source. It looks for specific patterns in the pulse repetition frequency, the rhythm of the radar. If that rhythm matches a known threat, the AI flags it immediately. It's like Shazam, but for surface-to-air missiles. But what happens when the AI sees something it doesn't recognize? In the world of air combat, an unknown contact is the most dangerous thing in the sky. It could be a friendly with a broken radio, or an enemy stealth fighter. Project Overwatch handles this using a probabilistic model. Instead of a simple yes or no, it assigns a confidence score based on the contact's behavior, position, and emissions. It's calculating the odds of a threat in real time. If the confidence is low, the AI doesn't just guess. It prompts the pilot for more data, or suggests a sensor sweep to clear up the ambiguity. It's a collaboration, not a replacement. The real magic happens when you combine these identifications into a combat ID. This isn't just a name, it's a full picture of the battlefield. The AI links data from every sensor on the F-35 into a single unified truth. This is what's known as sensor fusion, and Overwatch takes it to the next level. It can cross-reference a radar track with an infrared heat signature and an electronic emission to confirm a target's identity beyond a shadow of a doubt. By the time the pilot sees the target on their glass display, the AI has already done the heavy lifting. The pilot isn't wondering, what is that? They're deciding, what do I do about it? This reduction in cognitive load is the secret sauce. Studies have shown that a pilot's performance drops significantly when they're overwhelmed. By automating the boring parts of data analysis, Overwatch keeps the pilot in their peak performance zone. Think of it like the difference between driving a car while trying to read a paper map versus using a high-end GPS with live traffic updates. You're still the driver, but the mental effort is night and day. And this isn't just about comfort. In a high-threat environment, that extra mental bandwidth can be the difference between mission success and failure. It's about staying one step ahead of the adversary. Now, it's not all perfect. AI models can be tricked by adversarial signals, electronic decoys designed to look like something they're not. This is the new front line of electronic warfare. The developers of Project Overwatch are constantly updating the model to recognize these decoys. It's a literal arms race in the digital realm, where code is the primary weapon. But the most fascinating part? We haven't even talked about how this AI will change the way wars are actually fought, because the shift toward AI-augmented strategy is about to change everything. We are witnessing a fundamental shift in military strategy. We're moving from a world where humans do everything to a world where AI-augmented decision-making is the standard. Project Overwatch is the tip of the spear. In the future, a single F-35 pilot might act as a quarterback for a whole fleet of autonomous drones. The AI would handle the micro-decisions, while the human focuses on the big-picture strategy. This kill web approach allows for a level of coordination that was previously impossible. It's about creating a network that is faster, smarter, and more resilient than any individual actor. But with this much power, you need serious guardrails. You can't just let an AI decide who to target without human oversight. That's where the technical guardrails of Project Overwatch come in. The system is designed with a human-in-the-loop requirement for any lethal action. The AI provides the identification and the options, but the pilot always makes the final call. It's a hard-coded limit. These guardrails are built into the very architecture of the model. It's not just a policy, it's a technical constraint that ensures the machine remains a tool, not a decision maker. There's also the challenge of human-on-the-loop systems, where the AI operates autonomously, but a human can intervene at any time. Balancing these two modes is the next great engineering challenge. If the AI is too restricted, it loses its speed advantage. If it's too free, it risks making errors that a human would catch. Finding that Goldilocks zone is what the Nellis tests are really about. The goal is to create a system that is trustworthy, where the pilot knows exactly why the AI is making a recommendation. Transparency is the key to human-machine teaming. Looking forward, Project Overwatch won't just be for the F-35. The lessons learned here will be applied across the entire military, from naval destroyers to ground-based sensors. It's a multi-domain revolution. Imagine a world where every sensor in the theater is part of a single AI-managed network. A threat spotted by a drone is instantly identified and shared with every pilot in the area. That's the endgame. It's a future that feels like science fiction, but it's being built right now in the hangars of Nellis. And it's happening faster than anyone expected. So here's my take. Project Overwatch isn't just about making better fighter jets. It's about redefining the relationship between humans and machines in the most high-stakes environment on Earth. We're not being replaced, we're being augmented. We're being given the tools to see through the fog and make decisions with a clarity that was once impossible, and that is genuinely exciting. The F-35 was already a marvel of engineering, but with Overwatch, it's becoming something more, a true partner in the sky. And this is just the beginning.